Okay, so we're gonna explain the question number 2. This is the equation for the period of the pendulum, and this is our length number 1, that is 4, and our length number 2. After we multiplied our length number 1 times half percent, and it's 4.02. So now, changing time, that is 2 pi square root of our second length, that is 4.02 over 9.81, that is our gravity, minus 2 pi square root of 4, our initial length, over 9.81, that is our gravity, and this gives us an answer of 0.01002. So we're gonna do 0.1002, what's our final answer, over 0.01213, that is our answer of our initial length substituted in our equation, and we're gonna multiply it times 100 since we need to get the percent. Okay, now we gotta find the approximate percent change. So we use differentials. So what we gotta do is find our initial formula and we gotta derivate it. So what we have now, pi over the square root of L over G, length over gravity, and then we gotta multiply it by dx. And we found the dx by making 4.02 minus 4. So our second length minus our initial length, and we get 0.02. And then we just substitute in the numbers. We go pi over the square root of 4, which is our initial length, over 9.81, our gravity, and we multiply it by dx, and it is 0.0984. For finding the percent, we divide 0.0984 over 4.01213, which is the answer that the original equation must give us, and then we multiply it times 100, and we get that the approximate change or the margin of error, it's 2.4526%. So last we gotta find the approximate error in a day. So we do 60 being first our seconds times our minutes times our hours in a day, and we get that in a day we have 86,400 seconds. And so at last we just multiply this answer times our approximate percent change, and so we get that it's 2,119.0464 seconds, and we converted this to 0.5886 hours, and well, this means that we may have 0.5886 hours of difference than what the actual time is. So by the end of the day, this might be our difference in hours. The first thing we have to do to solve this problem is expand the parentheses, so it's gonna be 6x squared minus 2 times 6 over x times x squared over 2 minus x squared over 2 squared. So we're gonna solve it. 36 over x squared minus 12x squared over 2x plus, because this becomes positive, x to the 4th over 4. To make it easier, we're going to simplify with the x's, so we pass the x squared on top, going to the negative 2, minus 12 divided by 2, 6, 2 minus 1, it's going to be x plus x4 over 4. And now this is going to be, all the exponents are going to be plus 1, 1 plus 1, 4 plus 1. So 36x to the negative 1 minus 6x squared, and the exponent is going to divide the number, plus x to the 5th over 4 times 5. 36 over x, because this is to a negative power. It's gonna be minus 3x squared plus x to the 5th power over 20 plus c. You can do is 14x to the 1/2, which is the same as having it as a square root, times x squared minus 5x to the negative 1/2. Because you make it go up, you can have it down, plus pi times dx. Then you are going to multiply everything. 14x to the 5th halves minus 5, and your x is going to be 0, so this becomes a 1. 35 times 1 stays as 35, and plus 14x to the 1/2 times pi plus c. Everything is going to be plus 1 on top, 14 1/2 plus 1 also, so it's going to be 14x 7 over 2, and your exponent is going to become the denominator. And then we're going to simplify it. Negative 35, and you don't have an x, so you add an x, and here the exponent is 1, so it's over 1, it doesn't change, plus 14x to the 3/2 times pi plus c. Now it's going to be 2 times 14, 28 over 7, 4 x to the 7/2 minus 35 x, here 3/2, so it's going to be 2 times 14, 28 over 3, you can't simplify it, plus 28 x to the 3/2 pi over 3 plus c. Four square root of x to the 7th power minus 35 x plus 28 square root of x cubic times pi over 3 plus c.